I was sent this question today and it got me thinking, is the old spec A-level maths harder than the new spec? This is a question from a 2008 exam, I believe. So let's have a look at it. It says liquid is pouring into a large vertical circular cylinder at a constant rate of 1600 centimeters cubed per second. Okay. So we have 1600 centimeters cubed of liquid going into the cylinder. It is leaking out of a hole in the base at a rate proportional to the square root of the height of the liquid already in the cylinder. Okay, so we have some liquid in the cylinder with a height h, and the leak is proportional to the square root of h. Also, the area of the circular cross-section of the cylinder is 4,000 centimeters squared. Part A says showed that at time t seconds, the height h of liquid in the cylinder satisfies the differential equation dH on dt equals 0.4 take k root h, where k is a positive constant. Let's firstly recognize what this sentence means. The leak is at a rate proportional to the square root of the height of the liquid. So if we introduce a constant of proportionality, we can say this liquid is some constant multiplied by the square root of h. Okay, that's what it means to say it's proportional to. Okay, so we have the water going in at a rate of 1600 centimeters cubed, going out at a rate of c root h centimeters cubed per second. So that means we can calculate the total change in volume with respect to time. So that's the first thing I'm going to write down. dV on dt, considering both the input and the output, will be positive 1600, subtract the leak. So subtract c root h. Okay, so that's dV on dt. We also know, or we can write down an expression for volume. This is going to be the height for a cylinder. It's the height multiplied by the cross section. So h pi r squared. We know the area of the circular cross section is 4,000. So this would be 4,000 h. And to write an expression for dH on dt, we're going to use this equation or this relationship here. dV on dt multiplied by dt on dH equals dV on dH. Think about that as the dt sort of cancelling out. It's a differential equation relationship. So we have dV on dt. We can find dV on dH by differentiating this expression. So if we move that down a bit, if V equals 4,000 h, then dV on dH will be 4,000. Okay, so now plugging these expressions into this equation, dV on dt is 1600, take c root h, multiplied by dt on dH. This equals dV on dH, which is 4,000. Then rearranging so that dH on dt is the subject. Well, multiply by dH on dt on the right hand side, divide by 4,000. Then we get 1600 take c root h divided by 4,000. 1600 on 4,000 is 0.4. Then we have some constant divided by 4,000. That's just going to give us some other constant, which we can call k. Okay, so then we have dH on dt as required. Okay, part B says show that k equals 0.02. Oh, sorry, when h equals 25, water is leaking out of the hole at a rate of 400 centimeters cubed per second. Show that k equals 0.02. Okay, so when h equals 25, what do we have? So we're looking at this expression here. C root h equals 400. That's the leak. But also h equals 25, so we can plug that in as well. So we have the square root of 25 equals 400. Now you can let these be negatives if you want. You can let this rate be negative, negative 400, negative c root 25. But you see the negatives will just cancel out. So whether you write the negatives there or not doesn't really matter. Then square root of 25 is 5, so we're going to have c equal to 400 divided by 5, which is 80. So the constant in this expression is 80, so that c there is 80. And then to work out k, well, we had 80 on 4,000 was k, right? Remember, we did c divided by 4,000 equal k. So k is equal to 80 on 4,000, which gives us 0.02 as required. Okay, and c says separate the variables of the differential equation dh on dt to show that the time taken to fill the cylinder from empty to a height of 100 centimeters is given by this integral here from 0 to 100 of 50 on 20 take root h dh. Okay, let's go down the page a little bit. For part C, let's write down this whole thing again. So dh on dt equaled 0.4 take 0.02 root h. Here what we want to do is rearrange in terms of dt. So multiply by dt, divide by this expression, we'll have that dt equals dh over 0.4 take 0.02 root h. And then we can integrate both sides. Okay, so this is going to be an integral in terms of t. This one will be in terms of h. The integral of dt is just t. Then we have t equals the integral of 1 over 0.4 take 0.02 root h with respect to h. And then we just need to look at what we need to get to. And hopefully you can see they've multiplied the numerator and denominator by 50. You know, I think that's fairly clear. You've got to wonder, like, how would they get a 50 there? And then you think, okay, they probably just multiplied all of these numbers by 50, and it turns out 0.4 times 50 is 20, and 0.02 times 50 is 1. So we can just multiply everything by 50, the numerator and denominator, and we get t equal to the integral of 50 on 20 take root h dh. And then if we want the time taken to fill to 100 centimeters, to find that time, we want the time from when h equals 0 to when h equals 100. And then we would subtract those two times to get the total time. In other words, we're taking this integral from 0 to 100 of all of this. That would give us the time taken to fill up to 100 centimeters. And then we have that integral as required. Okay, so that was parts A, B, and C. Zoom out a little bit so we can see those. Let's get on to the hard stuff though. So part D was the 6-mark question, the big part of this question. It says using the substitution h equals 20 take x squared or otherwise, find the exact value of this integral that we just found. Okay, I am going to use that substitution. There are other ways to take this integral if you want to do it differently, but I will use this substitution as I think it makes the most sense. So let's write that down again. We want this integral from 0 to 100. And we're going to make this substitution. So let's say let h equal 20 take x all squared. So now, because we have the square root of h, this will just be 20 take x. So this is going to be the integral from 0 to 100 of 50 over 20 take 20 take x. So we've taken the square root of something squared. And then we can simplify that a little bit. So that will be 20 take 20. Also, I will factorize out that 50. So this is 1 over 20 take 20 is 0. Then we have negative x, which is just x. And this is dh. But because we have an x in here, we want dx. So we want to differentiate this expression. dh, using the chain rule here, this will be 2 times 20 take x multiplied by the derivative of the function inside the brackets, which is -1 dx. Simplifying this, this would be -2 times 20, -40, and then plus 2x dx. So now we're going to substitute this in for dh. So let's do that now actually. So rather than writing 1 dh, we're going to write 2x take 40 dx. But now that we've changed what we're integrating with respect to, we need to change the bounds as well, because it's no longer in relation to h. So now we need to find when h equals 100, what will x equal? So we would have 100 equal to 20 take x all squared. You can see here x must be 10, right? Because 10 squared is 100. So x equals 10. And then we have when h equals 0, 0 equals 20 take x squared. So x equals 20. So now our bounds are from 20 to 10. Okay, let's simplify a bit more. Let's factorize the 2 out. And in here we have now x take 20 over x. But we could separate these terms. So x over x is 1. Then we would have 1 take 20 on x with respect to x. Alright, this is simplified nicely. Now we can find this integral. This will be the integral of 1 is x. The integral of 20 on x is negative 20 log x. And this is from 20 to 10. Now we need to plug in those bounds. This will be, well, I didn't need those brackets there. This will be 10 take 20 log 10 subtract 20 take 20 log 20. And then let's keep simplifying. So 10 take 20 is negative 10. And then we have positive 20 log 20 take 20 log 10. Now we have logs with the same base. We can divide the term inside the log. So this will be 100 multiplied by negative 10 plus 20 log 20 divided by 10 is 2. So negative 10 plus 20 log 2, and then expand out that 100. We have negative 1000 plus 20 times 100 is 2000 log 2, and we are done. They asked for the exact value. That's as simple as we're going to get it for an exact value. Nice. Finally, part E says, hence find the time taken to fill the cylinder from empty to a height of 100 centimeters, giving your answer in minutes and seconds to the nearest second. This is just asking you to get or evaluate this answer as a decimal in minutes and seconds. If you plug that into a calculator, you get some decimal that will be in seconds, because we had the volume and time in centimeters per second. So this answer is in seconds. Then you need to divide that by 60 to get in terms of minutes, and you'll have some seconds as well. If you do that, you will get an answer of 6 minutes and 26 seconds. There you go, a differential equations modeling question. What do you think of that one from the old specification? Let me know in the comments. Please leave a like if you appreciated this video, and I'll see you in the next one. Bye for now.